SN1 versus SN2. What is the basic difference between these two mechanisms? SN1 is a substitution nucleophilic unimolecular. SN2 क्या था? Substitution nucleophilic bimolecular. So these are the basic difference. First difference is SN1 follows first order kinetics. SN2 follows second order kinetics. Like in case of SN1, the rate is directly proportional to the concentration of reactant only. But in case of SN2, the rate is directly proportional to concentration of reactant as well as concentration of nucleophile. So there are two molecules on which rate of reaction depends. That's why it's called bimolecular. In SN1 there is only reactant on which the rate of reaction depends. That's why it's called unimolecular. In SN1 carbocation is formed as intermediate, but in SN2 no carbocation is formed. As we already discussed that SN1 reaction takes place in two steps. First step में carbocation बनता था. That step is a slow step, rate determining step. लेकिन SN2 में हमने देखा है कि that take place single step. Nucleophile attack from the back side. That's the next point. Nucleophile attack carbocation from both sides, resulting in racemic mixture. But in case of SN2, the nucleophile attack from opposite side. Like suppose we have this carbocation formed. This carbocation is an intermediate. And what is the hybridization of this carbon is sp2. It means this carbocation is planar. This is in one plane. Nucleophile can attack from this side, can attack from this side. Means it's just like this one plane. Nucleophile can attack from this side, can attack from this side. Give rise to both the isomers, like T and L. That's why we get the racemic mixture. But in case of SN2, as we already discussed that this is the transition state. Like here is your leaving group and here is your nucleophile. The nucleophile always attack from the back side, or you can say from the opposite side of the leaving group. As you can see here, nucleophile attack from the opposite end of this leaving group. So inversion takes place. Okay. Inversion means when the dextro change into Leo change into dextro. That is known as a Walden inversion. As the dextro change into Leo change into dextro. But in this case, if you start with dextro, you will get both. If you start with Leo, you will get both. You get a racemic mixture. Because when carbocation is formed as intermediates, then the nucleophile can attack from either side to get the equal molar amount of P and L. Next में point आ जाएगा about the reactivity of haloalkanes. SN1 में कार्बोकेटाइन जो है वो बनता है, तो 3 degree alkyl halide more reactive than 2 degree alkyl halide, more reactive than 1 degree alkyl halide. और यहाँ पे अगर reactivity देखें तो 1 degree is more reactive than 2 degree, 2 degree is more reactive than. यहाँ पे हम कंसीडर क्या करते हैं? steric hindrance around this carbon. यहाँ पे क्या करते हैं? कंसीडर stability of carbocation. So these are some basic difference between the SN1 and SN2 mechanism. So this is the most important point, that when the nucleophile attack on, in case of SN1 you can say a racemic mixture is formed, but in case of SN2, Walden inversion takes place. This is the most important point. Next is the examples of nucleophilic substitution reactions. So like first example is substitution by hydroxyl group. formation of alcohol. So when the alkenes are treated with like ArX, KOH, aqueous, any base, alkali you can see, that may be KOH, that may be NaOH, moist silver oxide. When you heat this, you will get ROH plus HX. Sorry, KX. So here the nucleophile is your OH negative ion. That nucleophile attack on the carbon. Here, like this is your nucleophile. Attack on this. This is the leading group. So you get the product. Okay, for example, if we have CH3, CH2, Br, adding KOH aqueous, heat. What happened here? That the nucleophile OH negative ion will attack on this carbon, Br gets removed. Okay, so the product form is CH3, CH2, OH plus KBr. So ethyl bromide that changes to ethyl alcohol. This is your ethyl bromide. This is ethyl alcohol. So this is the first reaction. This reaction can also take place in the presence of moist silver oxide. Okay. Suppose we have CH3, CH2I plus you put here AgOH, or you can add here moist silver oxide. That is also written as moist silver oxide. You will get the same product, ethyl alcohol plus AgI. So this is the first reaction of an example of nucleophilic substitution by hydroxyl group. So we can change the alkyl halide to alcohol. Second is substitution by alkoxy group. And the substitution by alkoxy group. Formation of ethers. Here, second reaction. Now in this reaction what happened is that we have an alkyl halide which is there is a polar bond. When you are adding RONA like sodium alkoxide. Okay, this is a sodium alkoxide. Here this OR negative is a nucleophile, like you can see here. This part is a nucleophile. If you attack on this, X is removed. So what happened is, the product is formed is ROR. Okay, so this ROR is ether plus NaX. So in this way, alkyl halide that changes to ether. Like if you take an example like CH3, CH2Br plus CH3ONA. This is ethyl bromide. Okay, and this is your sodium methoxide. Here is your nucleophile, that is methoxy. This part is nucleophile, attack on this, Br is removed. What to get is ethyl methyl ether. So any ether you can prepare from this. This is your ethyl, methyl, ether. So this reaction is called Williamson synthesis. So इसी reaction को हम बोलते हैं Williamson synthesis of ethers. ये ether chapter आएगा उसमें भी हम करेंगे. So this can also be obtained by silver oxide. Like if you take 2 mole of say ethyl bromide, adding Ag2O, silver oxide, you can get diethyl ether. But this method is used to prepare only the symmetrical ether. This is also negative. So ये second reaction हो गया. Third reaction is another nucleophile we will take. That is a substitution by carboxylate group. That is RCOO negative. बनेगा क्या? Formation of esters. Esters will produce. For example, if you take alkyl halide, adding sodium or silver salt of carboxylic acid. This is your silver salt, which is nucleophile here, as this bond is between positive and negative. So this whole portion RCOO negative is a nucleophile. Attack on this X is removed. So RCOOR plus AgX. This is your ester. In this way, alkyl halide can be changed into ester. For example, if we take here methyl bromide, adding say silver acetate. Okay, this is here silver acetate. What happened is this negative ion attack on this. This is a nucleophile now. So you get a CH3, CO, OCH3 plus ADP. This will be your methyl acetate. So methyl acetate is produced. This is the third reaction. Fourth is, I will again change the nucleophile. Substitution by cyano group. Formation of nitrile, or you can say cyanide. Formation of alkyl cyanides. Now, in this case, we will take alkyl halide, adding it to KCl in alcoholic medium, not in water. Keep in mind, here the medium should be alcohol, which is nucleophile here. This portion. This portion is nucleophile. Attack on this to produce RCl. This is your alkyl cyanide. Suppose we start with methyl bromide, adding KCl, alcoholic. What to get is CH3CH, cetonitrile plus KBr. This is the ethane nitrile, or common name is cetonitrile. Ethane nitrile. This is 1, this is 2. So this nitride which we prepared here, that has a further many applications. Like if we have this alkyl cyanide, we have various applications. Like if we do its hydrolysis, acid hydrolysis, then this CN group that directly change into COOH, and ammonia is formed as a byproduct. This is your product. If you do it with like if you are adding water, means partial hydrolysis, that's called. Adding water in the presence of some peroxide like H2O2 and basic medium. This is your partial hydrolysis. To get is a amide. So amide is your product. If we add sodium in some alcohol, say ethanol, this is reduction, is called Mendes reaction. Okay, this is basically reduction. So what happened is hydrogen added to this carbon and hydrogen added to this carbon to get our CH2NH2 amine. So this is the application. When you get cyanide, that cyanide can be used to prepare carboxylic acid, can be used to prepare amide, can be used to prepare amine. So this is further applications of cyanide which we are preparing, and one more important point here is that when you do this reaction, as you can see in reactant we have only one carbon, and you can see in product we have two carbon. It means this reaction can be used for step up बोल सकते हैं, या इसको हम ascending of the series भी बोल सकते हैं. Ascending का मतलब होता है increase करना, ascending of series, या इसको बोल सकते हैं step up. जब किसी भी रिएक्शन में आपको 2 कार्बन से 3 करना है, 3 से 4 करना है, you can use this reaction by one way or other. Okay. Next is substitution by isocyano group. Substitution by isocyano, this reaction. Formation of alkyl isocyanide. Now in this reaction, we start with alkyl halide like ArX, adding silver cyanide AgCN alcoholic. When you heat this, you will get isocyanide, means R and C plus AgX. This is isocyanides, alkyl isocyanide. Suppose we start with CH3, CH2Br, adding AgCN. And to get is CH3, CH2, and C plus AgBr. Similarly, if we see that in the previous reaction, if we react it with KCN, you get CH3, CH2, Cn. So there is a difference in the product formation. That is very important. Haloalkenes, when react with KCN or NaCN, form alkyl cyanide as the major product. But when it reacts with the silver cyanide, AgCN, it forms isocyanide as the major product. That we are going to explain this now. This is a very important